Assalamu alaikum wa rahmatullahi wa barakatuh. I welcome all of you to my chemistry class in which I'm going to discuss today the states of matter, which is unit 1 according to the new IGCSE syllabus, which includes the states of matters, all the three states of matter as 1.1 and as well as diffusion 1.2. So these are the subtopics which we will be discussing categorically. Okay, so I have divided the whole topic or whole chapter number 1 in 3 lectures, and in lecture number 1 I'll be discussing particle theory of matter. In lecture 2 the change of states along with heating and cooling curves. We will be explaining heating and cooling curves in the light of kinetic particle theory. And in lecture 3 we will see the effect of pressure and temperature on volume, as well as diffusion and a rate of diffusion. So we'll be discussing what are the factors which affect the rate of diffusion. Right, so let us start with the recap. In last video I discussed about the substance and particles, and I mentioned there that substances are made up of tiny particles, right? So particles may be an atom, which is the smallest particle that cannot be broken chemically. When we write Na, it means we are writing an atom of sodium substance or sodium element, right? So when we write Cl, so we mean that it is a single atom of chlorine, which belongs to 7th group of the periodic table. When 2 or more atoms they combine chemically, so they are called either molecules or formula units. So if we write NaCl, it means it is a group of 2 atoms, sodium and chlorine. So it is an ionic compound, so the smallest unit or the group of atom is called formula unit of sodium chloride, whereas these 2 are covalent compounds, so there's the group of atoms, they are called molecules, a group of 3 atoms in which there are 2 atoms of hydrogen bonded individually to 1 atom of oxygen. So this is a single molecule of water. And NH3, a group of 4 atoms, 1 of nitrogen and 3 of hydrogen. So a group of 4 atoms is a molecule of ammonia gas. So when an atom or group of atom gets a positive or negative charge, so atom and or group of atom, they are called now ion or charged particles. So this is sodium cation and nitrate anion. In nitrate, a group of 4 atoms, it gets overall 1 negative charge. Okay, so we must be very clear about particles before moving forward. So starting particle theory of matter, basically particle theory of matter is of great importance, right? Because it provides a reasonable explanation for the matter behavior, right? Secondly, it conveys an important concept that matter particles are always in motion. If they are in solid, they vibrate, and if they are in liquid, they just slide over each other, and in gaseous particles they randomly move, right? So they are in continuous motion. So as a result, the particles model can explain the properties of the material states, right? The states of matter of solids, liquids and gases. So coming to the postulates of particle theory, the first postulate is that matter is made up of tiny particles, atoms or molecules we discussed earlier, right? So you can look at the diagram. This is a single atom in which protons and neutrons can be seen inside the nucleus as subatomic particles, whereas third subatomic particle, electrons, revolve around the nucleus in orbits or shells, right? And this is a molecule. Why this is a molecule? Because these are atoms, a single atom, another atom, another atom. So these different atoms, they are bonded together to form a group of atoms called molecules. So matter is made up of tiny particles, atoms, or molecules. The second postulate is that each substance has unique particles which are different than the particles of other substance. So have a look on the diagram. You can easily distinguish the particles of different substances. This is 2 atoms of hydrogen. Here 2 atoms of hydrogen are bonded together to form hydrogen molecule, and this is the molecule of oxygen gas, and this is the molecule of water, right? And this is the molecule of carbon dioxide, in which carbon is bonded to 2 individual oxygens. So you can easily identify that each substance has its own or unique particles, right? Moving on, the next postulate, particles of matter are held together by strong or weak forces. So there are forces between molecules. So molecules, they attract each other, which helps them to be held together or to close together, right? So for example, oxygen is of water molecule. If suppose that it is a water molecule, so oxygen of water molecule is attracted by means of a force with hydrogen of the other water particle, right? And hydrogen is attracted by oxygen, and oxygen is attracted by hydrogen. Am I clear? So this is by means of these forces, the particles, they come closer to each other and they are they are held together, right? Fourth postulate is that particles of matter are in constant motion, right? If they vibrate, as I told you earlier, that they are in constantly motion state. So these arrows show that particles, they move from one place to another. If they are tightly packed, they just vibrate about their fixed position. If they have a space to move, they move here and there within the structure, right? So the last postulate of particle theory of matter is that temperature affects the speed of particles. If we increase the temperature of a substance, of a material thing, so the particles, obviously they move faster. So the higher the temperature, particles move faster. So you can observe in the diagram that particles, they are, as temperature increases, particles, they move faster, right? So as I told you earlier that the particle theory basically describes the properties of solids and solids, liquids, and gases. So we can fill this table according to the particle theory of matter. Right, these are the aspects we can define or describe the properties of the 3 states of matter one by one, right? So you can look at the diagram. So particles in solid state, they are tightly packed or orderly in layers. So arrangement of particles can be written as they are orderly arranged in layers, right? So we can write orderly in layers. Whereas liquids, they are not in layers, they are randomly arranged in, not in layers, right? Randomly, not in layers. Whereas gas particles can be written as that randomly away from each other. They are also random, they have random arrangement, and particles are away from each other, right? Proximity means packing, how close these are. So we can say that in solid, particles are tightly packed, okay, tightly packed. Whereas in liquid, we can write they are packed but not tightly. So they are loosely packed, right? Whereas in gas, particles are far apart. As far as attractive forces between the particles are concerned, so a solid must have very strong attractive forces between the particles which holds them together in layers or very close to each other. So in liquid, particles are also closer to each other. So we can also say that strong forces, right? Strong, but not, or you can say not like in solids, okay, or weaker than solid. So in gases, we can claim that forces are very weak. So that's why particles, they are far apart. Movement in particles, as you know that there are no spaces, so particles will obviously move or vibrate or oscillate about a fixed position. So we can write vibrate about fixed position, right? And here particles, they move over each other, slide past over each other. So slide over each other in liquids, slide over each other, right? And in gases, they move randomly in straight lines, randomly in straight line until and unless they collide with the wall of the container or other particles. So based on these arrangement, we can describe the volume and shape of solid, liquid and gases. So these physical properties can be described easily, that solid, they have a fixed volume, or definite, you can say definite volume, right? Why definite volume? Because when solid is kept or is taken away or taken to another place, so it has the same volume, so volume is not changed, right? But when liquid has also its volume definite, because 25 centimeter cube water will remain 25 centimeter cube if it is transferred from a beaker to a glass, right? But indefinite volume, or gases take up the volume of the container, right? Shape is also definite. Solids have definite shapes, but liquid, they change their shape if they are transferred to another container. So liquids, they take up the shape of the container, right? And gases, obviously, they will also take the shape of the container. So I hope in lecture number 1 we have completed the particles theory of matter, which describe the properties of solids, liquid and gases. So till the next video, very next video, which is the continuity of the chapter, so hopefully you will join in my lecture number 2 as well. So till the next video, take care. Allah Hafiz. Assalamu alaikum wa rahmatullahi wa barakatuh.